Hey students, in this video I'm going to go over the review for the first part of Unit 2 test. I'm going to only go on the problems on the left side, go over those, and then you have to practice the ones on the right side. Alright, so for this first problem, it says use the figure below to answer the following questions. Name the segment parallel to EF. So we look at EF. EF is that segment way back there. So we look at parallel, we can just kind of see, oh, this line right below is parallel to that. So we can say segment CB is parallel. Now, this is only one example out of all the others that are parallel. If you envision this figure as a three-dimensional shape, we're looking at a prism. So all of these lines right here would be considered parallel to it. All right, and let's try another one. Name a segment perpendicular to AB. So if we're looking at AB, we're looking at that segment right there. And that, you need to recall that perpendicular means two lines intersecting at 90 degrees, exactly. So if we look at this and we look at this line right here, that one is kind of slanted, so it's probably creating an angle. The other thing we can do is look at this flat surface down here. And if you look at the shapes that these are creating and also the definition of a prism, these sides are always going to be rectangles. So that guarantees that these corners right here are 90 degrees. Therefore, the corner that BA and DA create, it's also a 90 degree. So we're going to say that the segment DA or AD is what's creating that perpendicular set of lines. All right, another one is name a segment skew to CD, segment CD. So for that one, we need to think of the directions that these lines are going. We have a line going this way, and we need to look for a line that is going opposite direction, meaning it's never going to intersect with this. It looks like IJ can be considered one of them. HG can also be considered another. So anything that is another dimension but never intersecting with this line can be considered skew lines. We can also talk about maybe back here, skew lines will be this going this direction and then G and J crossing another way. It looks like it could intersect, but it won't because HI is the one that will intersect with CD, but not GJ. So just keep in mind about all the dimensions that are happening here. I'm just going to use the example of HG as the segment that is skewed to that. I know it's a little bit complicated, all this vocabulary, but hopefully you understood that. Number 2 is saying use the figure below to identify the angle pairs that are corresponding, consecutive interior, alternate interior, or alternate exterior. So one at a time. Let's look at one at a time. So first we have the angles 1 and 11. So I recommend you to sketch these somewhere else, somewhere that you can analyze. So if we look at angles 1 and 11, we're looking at 1 right here and 11 right here. This angle, this angle. So we can say once again that identifying the transversal can help you see if they're alternate or if they're consecutive. One is on the left side, the other one's on the right side of that transversal, so they are going to be alternate. And then as far as interior or exterior, you got to look at the parallel lines. Inside is interior, outside is exterior. So these are alternate exterior. The next one we have 9 and 13. So angle 9 and 13. So we're looking at these two lines right here, 9 and 13. The fact that these two lines are kind of going at an angle, that means that these won't be parallel. But as far as what type of angles these are, these both will be corresponding angles because you have an angle happening, and if you slide it, this is the same position. Not same angle, but the same position. Top left, top left. So this is a pair of corresponding angles. Okay, the next one is 3 and 10. 3 and 10 are on this side. So 3 is right here, 10 is right here, and then the transversal line. So we have both of these on the same side, that's consecutive. And then if you analyze the parallel lines, they are inside the parallel lines. So it's consecutive interior. Last one, 2 and 8. So 2 and 8 are on the top, 2 right here, 8 right here. And identifying the transversal helps you see if they are alternate or consecutive. So alternate because they're on opposite sides, and then interior because they're inside. Alternate, interior. All right, let's move on to number 3. Number 3 says if the measure of angle 1 is 108 and they need you to find the other measurements, it will help if you kind of filled in all the angles, kind of going with the pattern. So picture this, 108 right there. And 108 is across this angle, so that will be 108 as well. If both of these are 108 and this creates a linear pair, we can assume that this is 72. 72 plus 108 is 180. And if this is 72, then vertical angle to that is also 72. So that fills in all those angles. Now we need to kind of slide and replicate all the angles. And then we slide it again. These are the angles. And if we slide it one more time, you get this angle. So corresponding helps you fill in all of these angles. And you can always double check with alternate exterior, alternate interior, supplementary being the consecutive inside or consecutive outside. So now that we have all the angles, we look at measure angle 11, which is this corner, so 108. Measure of angle 5, which is this corner, so that's 108. Measure of angle 2, which is that, so it's 72. And measure of angle 10, which is that, so it's 72 as well. All right, so hopefully this has helped you understand that problem. Let's look at the back. We have find the value of x so that p and q are parallel. So applying the vocabulary we just reviewed earlier will help you find these. It is pointing to this angle, so let's shade that in, and then this angle. So that, if you look at the transversal, we are looking at consecutive, because they're on the same side, interior, consecutive, interior. And anything that has to do with consecutive, whether you have inside or outside, they are always going to add up to 180. So two angles that add up to 180. In this case, we're going to write 12x minus 11 plus 4x minus 1 equals 180. And then we solve for x. So we have 12x plus 4x, that's 16x. And then we have negative 11 minus 1, that's negative 12. Then we move the 12 to the other side, and we get 16x equals 192. And when you divide 192 by 16, you get, I believe, 12. I don't have my yellow calculator, so I'll check on my phone real quick. Okay, so it is 12. And that's the answer. It's asking you to identify the theorem, so that's the theorem, and then this is the x. Let's try it once again. Here, solve the value of x for these two angles. So these two angles seem to just slide. So anytime you have the word slide in your head, it's corresponding. If they are corresponding, you need to remember that anytime you have alternate exterior, alternate interior, along with corresponding. Those are all congruent. They're all the same size. So therefore, we can write that these two are equal to each other and solve for x. So we're going to move the 11 to the other side. 3x equals 4x minus 12. Move the x to the left side, so minus 4x. And we get negative 1x equals negative 12. So therefore, we divide by negative 1 and x equals 12. You can pause or rewind if this was too fast for you. But yeah, that's just solving for x. So the answer here is x equals 12. And as far as what theorem or postulate, we're going to say corresponding angles. All right, let's try number 6. We have the another one with 24, actually 16 angles, and it's just asking you for which lines are transversal to angles 7 and 12. So the transversal here will be this one. So that's line D. And then it says if 7 and 12 are congruent, then which lines are parallel? So therefore, these lines will be the parallel lines, since that will be the transversal. So line A and line B. All right, let's try the next one. We have write the converse, inverse, and contrapositive of the given conditional statement. So this is remembering about P leading to Q. So if a triangle is equilateral, then it has three congruent sides. So that's P and that's Q. Converse will be Q reversing this, Q, then P. So we're going to have if a triangle has three congruent sides, then it is equilateral. All right, for inverse, it says to have the original statement, but just opposite. So negative, or the opposite of P, leads to the opposite of Q. So if a triangle is not equilateral, then it does not have three congruent sides. And the last one is contrapositive, which is this but opposite, or the converse but with the knots. So not Q leads to not P. So we're going to say if a triangle does not have three congruent sides, then it is not equilateral. Okay? All right, last two problems. We have draw a counterexample to the following statement. If two angles are congruent, then they are supplementary. So you need to think about this. If I have two angles that are congruent, are they always supplementary? So think of maybe a random number, angle 20, or angle equals 20 degrees, and you have a congruent angle to that, you're going to also have 20 degrees. So are these supplementary? Supplementary have two p's, so that means they add up to 180. That is not true. So we're going to say false, because not every angle angle pair of congruent angles or congruent measures add up to 180. And the description could be in your own words. It doesn't have to be the same exact wording that I used. All right, here comes the challenging topic. the proof table. Every time we start the proof table, we want to start by filling in what you're given. It says, given that lines A is parallel to B and C is parallel to D, so that fills in two statements, and we're going to put the reason is given. We're trying to prove that angle 7 is congruent to angle 10. So angle 7 congruent to angle 10. So here we're going to have to think about how we can use this angle and another angle on this part. Let me just zoom in. So our relationship of angle 7 with another angle either on this side or this side. So like right here, we can say angle 7 and angle 3 are congruent. So we can say angle 7 is congruent to angle 3. And that is because of corresponding, it just slides down. We can now conclude that angle 3 is congruent to angle 10 because of substitution. Because if you notice, we are using the same notation, we just substituted these two. And the proof table could be written in so many different ways. But I think it's one of those that you just need to learn how to speak the math once again and understand the options that you have and use them where they need to go. But usually think about the left side being statements that this has to happen, and then the right side being why or how do they happen. All right, I hope this video helps you.